Hi, 8th graders. I am absent today, obviously, and so what you need to have is headphones, you need to have your binder out, I need to see your bell ringer, you need to have your notes and your practice page. We're going to do all three on this video. Now, I want to remind you that when it's a video that I've recorded, it's on YouTube now, feel free to pause this. If I'm going too fast, you can pause this and take your time as you need to. And there will be some times where I tell you to pause it, okay? So first of all, get out your bell ringer. Put your name on the top, and I'm going to go over a couple of these to help you out a little bit. The first 4 questions on your bell ringer today, you are taking fractions and squaring them. Now remember, when you square something, it's like multiplying it by itself. So this is going to be 4/9 times 4/9, okay? 4 times 4 is 16, 9 times 9 is 81. I want you to think if you can reduce this. Before you move on to any problem, try to see if you can reduce, okay? Well, I know 16 is just 1 and 16, 2 and 8, 4 and 4, and that's it. And none of those numbers can come out of 81. So that's my final answer, 16 over 81. So do that same thing for 22, 23, and 24, watching for things that can reduce. And then I want to help you out on 25. 25 is a little interesting. Solve the equation S equals LW plus 2WH for W. We're trying to get W by itself. This one is a little strange because there's 2 W's in there, and you can't combine them because there's a plus sign in the way, right? So I'm going to rewrite it down here below. We got S equals LW plus 2WH. I want W by itself. I know right here on that section, to get W by itself, we would divide by L, right? And I know on this section, to get W by itself, I would divide by 2 and H, because they're just all being multiplied, right? So this one's strange. I want you to draw a big division bar underneath. We're going to take out that L. We're going to take out that 2. We're going to take out that H. And these two are being multiplied by each other. But we have to also get rid of that plus sign, so we're going to bring that as well. I know this is strange, but if I do it to one side, I have to do it to the other. L over L on this side of the equation, L over L makes one whole. That's why it cancels out. 2 over 2 makes one whole. That's why it cancels out. H over H makes one whole. That's why it cancels out, okay? Now, when we're done, I know that we're left with 2 W's up here, but we're just gonna like call it a W. I know that's super strange. That's why I want to do this one with you guys. But now what's left on this side is what W equals. It's S divided by L plus 2H. Okay, and that's literally it. So I'm hoping you all get number 25 correct because I just did it with you. But what I would like you to do now is go ahead and pause this video and work on the rest of these problems. When you are done with this bell ringer and your name is on it, you may go ahead and turn it into the turn-in bin. Okay, go ahead and pause the video now. When you are ready to go, we can go ahead and get started with our lesson. So get out your notes, 2.5, similar figures. Before we begin, I want us to kind of like look at this word, similar. If you remember 4 lessons ago, don't get sick, sorry. Way over here in 2.1, we learned about congruent figures. And we said congruent means that they have to be the same shape and the same size. For example, when we looked over here, are they congruent? We said this was a no, because it was not the same size, same shape, but not the same size. And we could tell it wasn't by the same size because all of these different side lengths, right? Now down here, we knew that these were congruent because they were the same size, same shape, just, tipped over. Remember, congruent, same size, same shape. But that's not what we're doing today. Today is similar figures. Similar figures means they have to be the same shape, but they do not have to be the same size. To tell if figures or shapes are similar, you can compare their side lengths and their angles to see if they form a proportion. So these are your notes, right? I'm going to go ahead and pull up the actual book so you can see what we're doing in this lesson. Similar figures. Figures that have the same shape, but not necessarily the same size, are called similar figures. Triangle ABC is similar to triangle DEF, and here's why. They are the same shape. These angles are congruent. In other words, those angles are identical. This angle is identical to this angle. This angle is identical to this angle. If the angles are all the same, it doesn't mean that the side lengths have to be the same for them to be similar, as long as the angles are the same. Okay? Triangle ABC is similar to DEF. Two figures are similar when corresponding side lengths are proportional. Remember, a proportion is like a bunch of fractions that are just equal to one another. So like 1/2 is proportional to 2/4, okay? So if their side lengths form a proportion, and if their angles are congruent meaning identical, like the same, right? Then you can say that the figures are similar. We'll do an example over here back in your notes. Okay, hop over to your notes, right here. Similar figures. Next to similar figures, I want us to write same shape, different size. Oops. Okay, same shape, but different size. I'm going to highlight that yellow. Grab a highlighter and do that with me. Now down here below, I want us to talk about how their angles have to be congruent, but their side lengths do not have to be congruent, okay? So I'm going to say angle A corresponds to angle D. We're going to do the same thing for all these angles. Angle B corresponds to angle E, and angle C corresponds to angle F. Remember, corresponds means that they are the same. They are congruent. So next to this, I'm going to say all angles are congruent. Please remember, congruent means identical, okay? However, let's talk about their sides. AB is proportional to DE. Okay, so proportional means if this was like a 2, this would be a 4. They're proportional. I can take 2 and times it by 2, and I'd get 4. But now here's the thing. If I did say that that side length was a 2, and that side length was a 4, and let's say I say that this side length is a 3, that means EF would have to be a 6. Because I just told you 2 times 2 got me 4, I have to do it to the same thing to get 6. That's what a proportion is. It means that they are similar in the size, right? I'm going to go ahead and finish this. AB is proportional to DE. BC is proportional to EF. And then CA is proportional to FD. So things are similar if their side lengths are proportional. Okay, going back to the book. Which rectangle is similar to rectangle A? Rectangle A has a side length of 3 and 6. Rectangle B has a side length of 2 and 6. Rectangle C has a side length of 2 and 4. Each figure is a rectangle, so corresponding angles are all going to be congruent, right? They're all going to be 90 degrees, so that's fine. Check to see if corresponding side lengths are proportional. We're going to set up a proportion of rectangle A's sides. So the length of rectangle A right here is a 6. The length of rectangle B is also a 6. So they're going to make that proportion 6 over 6, which is equal to 1. Now we're going to do the same thing for the other side. We've got 3 and 2. Setting up that proportion, 3 is to 2. Now, is 3 halves the same thing as 1 whole? No. Since they didn't equal the same proportion, we'd say that's not proportional. Let's set up another proportion, but this time with these side lengths and rectangles C side lengths. 6 is to 4, so they put 6 over 4, which is the same thing as 3 halves when you reduce, is to 3 over 2. 3 over 2. Do you see how we got the same fraction at the very end? That means they are proportional. I have a few ways that we can find proportions. One way is you can turn them into fractions and see if they equal the same fraction. Another way is to do cross products. We're going to do that in a second. Let's go back to your notes. The triangles are similar. Find x. So sometimes it's not going to be asking you if they are similar. It'll just flat out tell you they are similar. Now go find x. Now remember how over here, if I said this was a 2 and this was a 4, and if this was a 3, this would have to be 6? And the reason why was because if I times this by 2, I have to also times this by 2 to make them similar, right? Same thing over here. But the way that we're going to solve for x, this isn't as easy, right? Because 6 times what gets you 9? Nothing nice. So instead of figuring it that way, we're going to write them as proportions. Now with proportions, the biggest thing that's like the most important thing is to keep similar things with similar things. What I mean by that is this. You can either say side length 6 is to side length 9 as side length 8 is to side length x. I'm going to use a highlighter. Don't do this part, okay? I'm just using this to show you. But do you see how I have 6 is to 9? See how that's big, or that short side is to short side? As long side is to long side. Long side is to long side. But then I also kept this triangle's numbers on top, and I kept these triangle numbers on bottom. As long as you're keeping like things with like things and not switching them around, then it's okay. Can I show you another way you could have set up this proportion? You could have set up this proportion saying the side length 6 is to side length 8, as the side length 9 is to the side length x. So once again, don't do this part. I'm just going to highlight to show you real quick. 6 and 8 are on the same triangle. 9 and x are on the same triangle. I kept the short side on top with the other short side on top. See, short side, and I kept the long side and the long side on the bottom. It really, really does not matter which way you write your proportion, either this way or this way, you will still get the same answer. And if you look, do you see how 6 is across from x here? And 6 is also across from x here? And 8 is across from 9? And 9 is across from 8? That means you're going to get the same answer no matter what. So for this case, what I'm going to do, I'm just going to choose this proportion to start with, okay? To solve for x, we're going to do cross products, okay? Here's how this works. You take the two numbers that are across from each other. Not this. 6 doesn't have a number across from him. 6 has an x across from him. So take the two numbers that are across from one another and times them. Okay? This is called cross products. It's also what I like to call, it's a little nickname. It's called times divide. Okay? You take these two that are across from one another and times them. Then divide by the guy who has nobody across from him. So here's the shortcut. Ready? Times divide. You'll take 9 times 8, and you'll get 72. Then divide 72 by the guy who didn't have anybody across from him. And then 72 divided by 6 is, whoops, my bad. 72, come on, 72 divided by 6 is 12. Now I know x is 12. Okay, so you have this in your notes, just like this, right? I want you to write down right here that this is called the times divide method. And then highlight that. That's called the times divide method. What we did is we took the two numbers across from one another, times them, and then divided by the loner. He's the loner because he has nobody across from him. He has an x. That doesn't count. times divide. I want to show you another method, okay? This other method is really, really helpful for when things are a little bit yuckier. And what I mean by yuckier is like this. What if x wasn't just x? What if x was like x plus 2, right? Then times dividing doesn't work as easily. Times and then divide, but then like what do you do about that mess, right? So let me show you the other way you can do this. We've got the times divide method. Now, you guys don't need to write this down because I don't know if you'll have enough room where you're at right now, but let me just show you it. This is why the times divide method worked. Cross products says that I can take this times this and set it equal to this times this, okay? This is called cross products. Let's take 9 times 8 and set it equal to 6 times x. Now we know I can rewrite that as just 6x, right? Go ahead and solve it. 9 times 8 makes 72. Can I solve this to get x by itself? Yes, we can. We can do the opposite of what's happening to x and divide the 6 to both sides. When I divide that, I'm going to get 72 divided by 6, and x will end up equaling 12. I want you to notice that the times divide method is actually exactly what we just did over here. It's just the shortcut. Did I eventually take 9 times 8? Yes. Did I eventually have to take 72 divided by 6? Yes. And then did I eventually get what x was? Yes. So times divide, think of it as like shortcut cross products, okay? Cross products say you can take this times this and set it equal to this times this. I've got 2 more examples down here. This one is saying, are they similar? So we have to like prove if they are or not. And then this one says find x. I want us to skip the are they similar for now, and let's just go straight to the find x, okay? Find x is very similar to what we just did right here. They are similar, find x. Since x isn't something weird like x plus 2 or 3x or x4 minus x plus 1, since x is just plain old x, we can do the times divide method. It's way faster. The only time I'd really say you want to do the cross products method is if x was funky, like 2x or 4 minus x, right? Something weird. Let's do the cross products or the times plus, or times divide, sorry. Now here's where kids mess up, is making the proportions. To make a proportion, you have to make sure you have like things with like things. I don't care if you say this is going to be 9 over 15 is equal to 4 over x. That works. I have this side with this side in one proportion, and then I started with that same side and went to this side in the other proportion. That's okay. Or you can say, let's go from this side to its corresponding side. So 9 is to 4 as 15 is to x. It's a bunch of analogies, really, right? I don't care which way you do it. Whichever way makes more sense to you, do that. In this case, I'm going to say 9 is to 15, so I'm keeping side links with side links on that one shape, is to. Now here's something you can't do. You can't say x is to 4. Here's why not. Do you see how this is my short side right here over my long side? You have to continue the same pattern. This needs to be the short side. This needs to be the long side. This is the short side. So shouldn't that go with short side? This is the long side. So shouldn't that go with long side? So that's an example of what you can't do. You can't flip them like that, okay? So 4 is going to go on top. X is going to go on bottom. Okay. Now to continue on solving this, we're going to do times divide. Take the 2 that have a number across from one another and times them. Then divide by the loner. So it's going to be 15 times 4, which is, let me get this, 15 times 4, 60. I should have been able to have done that. Now divide by the loner. The loner is the 9. He has no friends across from him. And then 60 divided by 9, ooh, you get something grossy. You get 6.6 with a hat. That's what we're going to put. X is equal to 6.6 with a hat. I also know that 0.6 with a hat is the same thing as 6 over 9, which if you reduce that, take out a 3, you get a 2/3. So you could say, boop, 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 boop. You could say it's 6.6 with a hat, or you could say x equals 6 2/3. Once again, how we solve that is we did times divide. Okay? Okay. Back over here. Are they similar? I'm not missing a side length. Instead, I want to know, are they similar? What I'm asking is, do they form a proportion? So what we're going to do is set up a bunch of proportions and see if they equal the same thing. Okay? I'm going to do corresponding sides to corresponding sides on this one. And what I mean by that is I'm going to say 6 is to 9. So it would look like this. 6 is to 9. I'm going to write that down. 6 is to 9 as, I know 8 would go to 12. So I'm going to set it equal to 8 is to 12. And then our last side is 4 is to 6. If I'm starting over here for the numerator, we have to end over here in the denominator. Got to keep it the same, okay? Now to tell if they're similar, they should all be the same fraction. So what I'm going to do is see what each of these reduces to. 6/9 reduces to, if I take out a 3, take out a 3, that makes 2/3. Let's do 8/12. I can take out a 4 and take out a 4. That would make 2/3. And then right here, I can take out a 2 and take out a 2. That would make 2/3. If they all end up equaling the exact same fraction, then they are similar. So I'm going to say this is a yes. They are similar. Okay? Now that's pretty much it for the notes right now. However, I want us to do some practice problems. So what I would like you to do is pause this video if you need to finish the notes, but go get yourself a whiteboard and a marker. And I want you to do some problems with me. Go ahead and pause the video and get your whiteboard and marker.